Okay friends, so let us solve some more examples on plane and line. Find the equation of plane containing the following lines. What are the lines given? Z minus 1 upon 5, and the second line is now please note that 1 minus 4 5 and 1 minus 4 5 are the direction ratios of both the lines, and therefore these two lines are parallel, right? So what do we have on the plane? Since both the lines lie on the plane, there is one vector which is 1 minus 4 5. Let us take it as b1 bar. It is there on the line, on the plane. Second vector b2 bar is also on the plane, which is this, so it is of no use to us because it is the same vector. So let us not write it. There is no point in writing. Okay, what else do we have? Are the 2 points. These 2 points also lie on the plane. So let us take point A as 3 2 1. Let us take point B as this one, 2 minus 3 minus 1, and let us take point R as any general point, say x y z. So now we have got three vectors. One vector is AB, another vector is AR, and the third vector is this b1 bar. So since they are coplanar, their box product must be 0. AB bar, b1 bar, and AR bar, their triple product must be 0. So let us find AB bar here. What is AB bar? 2 minus 3, so minus I, minus 3 minus 2, minus 5j, and minus 1 minus 1 is minus 2k. Minus 1 minus 5 minus 2. You can also write it as 1 5 2. It will not make any difference. So now let us do the box product of AB bar, B1 bar, and AR bar. And the box product is going to be 0. So what we have here is 1 5 2, 1 minus 4 5, and what is AR? X minus 3, y minus 2, and z minus 1. Determinant is 0. Just do this. Minus 4z plus 4. Please, I may make a mistake. Please correct me. So after expanding this, we should be able to get the equation of the required plane. So let's expand it. Let's see what we get. Minus 4z plus 14 minus 5z plus 10x minus 1 is 14 into minus 5 minus 70 and 2y plus 8x minus 28 equal to 0. So 10x plus 8x is 18x minus 5y plus 2y minus 3y minus 4z minus 5z is 14 minus 70 minus 28 is 84. Divide by 3. And this is your answer. Some mistake with x here. This one is 25x. So x will be 25 plus 8. $33. So this will be 11. Yeah, this is the final answer. This is the equation of your required plane. Fine. So we have used the concept of scalar triple product is equal to 0. Let us solve the next example. Find the equation of plane through line of intersection of two planes. They are given and parallel to now equation of plane which passes through line of intersection of two planes is given by, suppose this is u and this is v, u plus kv equal to 0. So the equation of required plane will be 2x minus 5y plus 2z minus 6 plus k times equal to 0. Let us compile the terms in terms of x, y and z. So it will be x into 2 plus k plus y into minus 5 plus 3k plus z into 2 minus k, and minus 6 minus 5k will be 0. So what will be the normal along the plane? The normal along the plane will have coordinates. I am not writing ijk here for the sake of simplification. 2 plus k minus 5 plus 3k and 2 minus k. Now since this plane is parallel to the line, what is the vector along the line? 1 minus 6 7. Again I am skipping ijk. Now since the plane and line are parallel, the normal will be perpendicular to b. So the dot product of n and b is equal to 0 gives me the value of k. I substitute the value of k here and I get the answer. So let me do n bar dot b bar equal to 0. So n bar dot b bar equal to 0 gives me 2 plus k into 1 plus minus 5 plus 3k into minus 6 plus 2 minus k into 7, that is 2 plus k plus 30 minus 18k plus 14 minus 7k. So minus 18 minus 7 is minus 25. Minus 25 plus 1 is minus 24k. And this is 30 plus 2 is 32. 32 plus 14 is 46. This is 2k. So that is 25 minus 23 k plus 46, and that gives you k is equal to 2. Substitute k is equal to 2 here and see what you get. 2 of 4 plus 2 is 6, so 6x, k equal to 2, so 3 to the 6, 6 minus 5 is 1, 2 minus 2 is 0, so z will not come, and if you put k equal to 2 here, 5 to the 10 minus 6 is 16. So this is your final answer. 6x plus y minus 16 is equal to 0. Okay, so it's a pretty simple example. We can easily understand how this sum has been solved. A plane through line of intersection of two planes. Okay, let's see a few more examples on planes. Okay, similar sum we are doing. Find the equation of plane passing through the line of intersection of and which is also perpendicular to the plane so this is the first plane and this is the second plane. So our required plane will be this is 4. Seven x minus 4y plus 7z minus 16 plus k times 4x plus 3y minus 2z plus 13. Let us rearrange terms. So this will be x into 7 plus 4k plus y into plus z into so what are the direction ratios of normal? 7 plus 4k look at the other plane. What are the directions of normal to this plane? If two planes are perpendicular, then the normals also will be perpendicular. It's obvious. If two planes are at right angles, suppose this is one plane and this is second plane. This is normal to the first plane, normal to the second plane. If these two planes are at right angles, then their normals also will be at right angles. So what all we are going to do is the dot product of n1 and n2 is going to be 0, and that gives me the value of k. So let us find k by doing the dot product. So this is 7 plus 4k into 1 minus 1 into this will give 4 minus 3k, and minus 2 into this will be equal to 0. That is 4 minus 3 is 1 plus 4, 5. 5k 14 is 0, and that gives me k equal to 3 by 5. The rest is simple. Just put k is equal to 3 by 5 in this equation. Just put k equal to 3 by 5 and you should get the answer. So let's still do that. Of course, it is nothing big about it. You can also do it on your own, but let us still verify. Four into 3 by 5. 3 into 3 is 9 by 5. So 1 5 are 35. 35 plus 12. 47. This is minus 20 plus 9, which is minus 11. This is 35 minus 6. It is 29. And this is 80 and 39 is 119. I think it is plus 13 in the original problem. I don't know, whatever it is. Let's take it as minus, makes no difference. You can multiply throughout by 5. That gives you the solution. Anyway, it is not important. What is important is how to do the procedure. So once you get k equal to 3 by 5, the rest is easy. And this is your final answer. I think that's pretty simple. Okay. Find the equation of plane which is passing through the point 1 minus 1 2 and is perpendicular to both the planes. And also perpendicular to again we will use the approach of coplanarity. Please note that if one plane is perpendicular to another plane, the normal of first plane will be parallel to the second. See the concept again. This is one plane. Suppose it is perpendicular to another plane. Then if I draw the normal to this plane, it will be parallel to this plane. As the two planes are perpendicular, normal to one plane will be parallel to another plane. So both these normals will be parallel to the given plane, or we can say that they are coplanar with the given plane. So what are the three vectors that we need to get the box product as 0? The first vector is the first normal n1 bar, which is this 1, 2, minus 3, that is r plus 2j minus 3k. The second normal is this one, 2i plus 3j minus 2k. We have a point 1 minus 1 2. Let us take this point as a, and we have a general point r, which is xyz. So we have the box product of n1, n2 and ar as 0, and that gives me the final solution. So 1, 2, minus 3, 2, 3, minus 2, and what is ar? X minus 1, y plus 1 and z minus 2. Please solve this determinant and you will get the answer. Please solve this. So 9 minus 4 is 5x, 2y minus 6y, and 3z minus 4z is minus 4 plus 12 is 8, 8 minus 15. So this should be your final answer. 5x minus 4y minus z minus 7 is equal to 0. Next sum, find the equation of plane which bisects the angle between the given planes. So this is the plane. This is another plane, and we want to find out equation of angle bisector. So let us take P x1 y1 z1 as a point on the bisector. Please note that every point on the angle bisector is at equal distance. Let me represent the plane by edges. You will understand it in a better way. Every point on the angle bisector is equidistant from the planes. So distance of point P from this plane must be equal to distance of point P from the second plane. That's all we have to do. So this is ax1, by1, cz1 like that. So ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square. This must be equal to, please note, plus or minus. When we will open, we will do plus or minus. Now we have got a mod. x1 upon under root of plus 36. When you open the mod, we must do plus or minus so that we will get two planes, one that bisects the acute angle and the other that bisects the obtuse angle. So we will get two equations. And in the final answer, we will drop x1, y1, z1 and we will write the answer as x, y, z. So let me do it here only. Instead of x1, y1, z1, we will write it as x, y, z. So once we'll do it with plus and the second we'll do it with minus. Just cross multiply. So 7 into this. That is 5x minus y. This is the first equation. In the second equation, we'll just put a negative sign here, so that what we'll get is 23x. This will become plus, so minus 7 minus 6, that is 13y. This will become minus 18, so we'll go on the other side, become plus 18. So 18 plus 14 is 32, and 21, this minus 24 becomes plus 45. So this is the one which may bisect the acute, and this is the one which bisects the obtuse. Next example. Find distance between the planes. What are direction ratios of normal to this plane? 2, -1, 2. And what are direction ratios of this plane? 4, -2, 4. Please note that they are proportional. This is direction ratio will be same as 2, -1, 2. It means these two planes are parallel. If two planes are parallel, then to find a perpendicular distance becomes pretty easy. All we do is pick up any point on the first plane and find its distance from the other plane. So we can pick up any point on the first plane. It is our choice. Let us find this plane. It is absolutely our choice. So what we can do is, on this plane, let us put x equal to 0 and z equal to 0. If you put x and z is equal to 0, you will get y equal to 3. So a point on this plane will be 0, 3, 0. Now let us find distance of this point from this plane. This plane is so what is the distance here? The distance will be ax1, which is 0, by1, which is -6, c0 is again 0, plus d upon under root of a square plus b square plus c square, that is, so the answer is 11 upon root 36, and that is 11 upon 6. Let me just check the answer. Yes, the answer is 11 upon 6. Now we'll do some complicated problems on locus. Some complicated problems on locus we will do. A variable plane which is at a constant distance 3p from the origin. So distance of the plane from origin is always 3p. It cuts off the coordinate axis in A, B and C. So it cuts the coordinate axis at points A, B and C. Suppose this is x-axis, this is y-axis and this is z-axis. and this plane cuts it at A, B and C. We are supposed to find the locus of centroid of triangle ABC. We are supposed to find the locus of centroid of triangle ABC. Okay, so let us take the coordinates of A as 3a 0 0. It lies on the x-axis, mind you. Let us take this as 0 3b 0. Coordinate of C as say 0 0 3c. Then the center of the triangle, the x coordinate of center of the triangle will be given by A, because it is 3a plus 0 upon 3, so it will be A. Y coordinate of centroid will be B, and Z coordinate of centroid will be C. So this is what we know. Now let us find the equation of plane. The equation of plane in the intercept form will be given by x upon 3a plus y upon 3b plus z upon 3c equal to 1. Right? Or we can say, let me write it here only, minus 1 equal to 0. Now the perpendicular distance of this plane from the origin is given to be 3p. So let us find out the formula for perpendicular distance. We already know that. So what is the perpendicular distance from the origin? 3p. And this 3p will be ax1. A is 1 upon 3 into 0 only. by1 is also 0. c01 is also 0. Plus d. D is minus 1 upon under root of a square plus b square plus c square will be c square. Is it correct? Fine. Please note, we have already established the situation in which the locus of centroid has a relationship x is A, y is B and z is C. Now let us square both the sides. So you will have 9p square will be 1 upon let us cross multiply. And just put x equal to a, y equal to b and z equal to c. 9 will cancel and you will get p square into 1 upon x square plus 1 upon y square. P square goes on the other side and the final answer is this. This is the equation of required locus. Next sum. A variable plane moves in such a way that sum of the intercepts on the corner axis is always constant. Sum of intercepts is always constant. We are supposed to find the locus of foot of perpendicular down to the plane from the origin. Locus of foot of perpendicular drawn from origin to this plane. Now in the intercept form, as we have already seen, the equation of plane is x upon a plus y upon b plus z upon c is equal to 1. These are the x, y and z intercepts. So we have got a relationship. It is given to us in the problem that a plus b plus c is equal to k. Now we want to find the locus of foot of perpendicular from origin. So let this p xyz be a point on the locus. Now what will be OP bar? OP bar will be xi plus yj plus zk. It is perpendicular to the normal. So what is the normal? So normal will be I upon a, j upon b and z upon c. And what is this is the normal to the plane. We also have a plus b plus c is equal to k, and the foot of perpendicular means this particular point also lies on this plane. So suppose we take this as x1 y1 z1, then you have this one equation x1 upon a plus y1 upon b plus z1 upon c is also equal to 1. Now the question remains is how to relate these two and get a plus b plus c equal to k somehow in our formula. So we have to rearrange the terms, think about rearranging terms and seeing how to incorporate ABC in terms of k in our equation. So what is the condition that we are going to impose here? Let us find the equation of plane. So equation of plane in the form of x1, y1 and z1. So what will be the equation of plane? We know that the direction ratios of OP are x1, y1, z1. So normal it's also x1i plus y1j plus z1k. Right? This is also the normal. Let us take any point xyz on the plane so that this particular point and OP they are at right angles. So OP bar dot PR bar is equal to 0. If you remember the normal form of the equation, then you have got OP bar dot PR bar is equal to 0. So what is PR bar? It is x minus x1 I bar plus this is PR bar. Now PR bar dot OP bar. OP bar is this, isn't it? N bar. So the dot product will be 0. So what is the equation of plane? X minus x1 into x1 plus y minus y1 into y1 plus z minus z1 into z1 is equal to 0. This is another form of equation of plane. I hope it is understood. This is another form of equation of plane. So now we can find the intercepts made in terms of x1, y1 and z1. So let us see the intercepts made by this particular plane, and the x-intercept is A, y-intercept is B, and z-intercept is C. Okay. So what is the x-intercept? The x-intercept is obtained by putting y equal to 0 and z equal to 0. So in order to obtain the x-intercept, you put y equal to 0 and you put z is equal to 0 in the equation of plane, and what you will get is if you put y is equal to 0, you will get minus y1 square. If you put z equal to 0, you will get minus z1 square. So the x-intercept is x1 square plus y1 square. Now please note that this is same as A. So x1 square plus y1 square plus z1 square is same as A. X1, sorry, upon x. So this is A. Similarly, if you want to find a y-intercept, you put x equal to 0 and z is equal to 0. You will get y1 and y1 square, and you will get the y-intercept as x1 square plus y1 square plus upon y1. That will be B. And similarly, you will get the z-intercept. Now sum of all these three intercepts we are going to equate to k, and that's our final answer. So what is the final answer of our locus? The x-intercept is upon x1 upon y1 and then upon z1. The sum is k. So you can take this common. In the final answer, while writing the locus, we drop x1, y1, z1 and we present the answer in terms of x, y, z. So the final answer in terms of x, y, z will be this. I know it's a complicated sum, a little bit complicated, but it will hardly be asked in MSCT, but it could be asked in competitive exams like JEE Advanced or JEE Mains. I think that should be enough. We have done enough examples on plane. I don't think anything else other than the sums that we have done so far will be asked in the exam. So all the best, and if you have any queries you can always mail me or send a message on YouTube. You can mail me at this address with your queries and I will be happy to help. Please note the double A. Okay, thank you so much.